Hello students, today's topic of discussion is strain gauge. So we will look into what are strain gauges and some other concepts as a part of this session. So strain gauge is a sensor whose resistance varies with applied force. We all know that force can be converted into pressure, tension, weight, etc. So whenever force, pressure or weight is applied on a strain gauge, its resistance changes. This change in resistance can be measured by electrical means. So let's have a look at this weighing machine that we all have seen in market. So this weighing machine is used to measure weight of grocery items. So this is the platform where you keep the material whose weight you want to measure. Strain gauges are mounted somewhere here. So when this weight is applied on strain gauge, its resistance changes. And there are various resistance measuring circuits that we have already seen, like we have seen what is a Wheatstone bridge. So with the help of Wheatstone bridge, this change in resistance can be converted into equivalent change in voltage. So you can consider strain gauges as a special type of resistance. When you apply force or pressure to this resistance, its resistance value changes. So when external forces are applied to strain gauge, stress and strain are produced. We are going to see in detail what is stress and strain. But before that, let's have a look at this diagram. This shows something called as semiconductor strain gauges. So yes, we are going to study types of strain gauges later in this course. So semiconductor strain gauge looks something like this. These are two leads which are available for making electrical connections. Okay, so let's have a look at what is stress. For that, consider this column. This is external force in form of pressure that we are applying in this direction. When we apply such kind of force, an internal force is produced by the object itself, which opposes this external force. So if this object receives an external force from top, it internally generates a repelling force to maintain the original shape. This repelling force is called as internal force. And when you divide this internal force with the cross-sectional area A, it gives us stress. So stress, which is denoted by sigma, is given by applied force in terms of pressure here divided by cross-sectional area. The unit of stress is Pascal or Newton per meter square. Now let's have a look at what is strain. For that, consider this bar. Assume that this is a metallic bar and we are applying force in both the directions. So basically we are trying to stretch this bar. The result of this is the length of bar is increased by a small amount. Let's denote it by delta L. So if L is the length of bar before application of force, L plus delta L is the new length after application of force. Changes are also observed in diameter of this bar. So initially the diameter is D0. When you elongate this by application of force, diameter decreases by a very small amount. Let's denote it by delta D. Okay. So the ratio of this elongation delta L to the original length L is called as strain. So strain is denoted by epsilon. Epsilon is given by delta L divided by L. Now this strain can be of tensile or compressive nature. So here we are trying to pull the bar in both the directions. We are trying to stretch the bar. So this is called as tensile strain, whereas we can also apply force in the reverse direction. Okay, so here if I apply force in this direction and this direction, we are trying to compress the bar. This is called as compressive strain. Now the value of strain is usually very small, and therefore we usually suffix 10 raised to minus 6 to the value of strain. So basically strain is a unitless number. Why? Because this is change in length divided by original length, so it's unitless. But because we suffix it by 10 raised to minus 6, most of the times strain is expressed as microstrain. So let's have a look at the relationship between stress and strain. Look at this graph. So when you apply strain to a certain object, stress is produced. Now to some extent, when you go on increasing strain, to some extent, the relationship between strain and stress is linear. Later on, there are some permanent deformations in the material. So this band is called as proportional limit. The region where stress and strain have linear relation is called the proportional limit, which satisfies the Hooke's law. Hooke is name of the scientist who came up with this concept. So yes, this is Hooke's law. The ratio of stress to strain is called as modulus of elasticity, which is constant for that particular material. So this is the equation which states the relationship between stress and strain. Now let's pause the video for some time. I request you to pause the video for say 2 minutes or something, and in your notebook write down the formula and unit for stress and strain. After you are done with this activity, fill in this blank. The relationship between stress and strain is given by dash and write the relevant equation. I hope that you have done with this activity. Let's move forward with the presentation. Now, this strain gauge that we have just seen, it doesn't have a lot of mechanical strength. So in market, if you go for strain gauges, you will find strain gauges which are bonded on some plastic base to give it mechanical strength, and they are also covered by a laminate thin film so as to isolate these strain gauges electrically. Now these two leads, they are brought outside and they are available for electrical connections. Okay, so yeah, so these, when you apply force in this direction or in this direction, the resistance will change, and this is connected to Wheatstone bridge, which converts this change in resistance into equivalent change in voltage that we have already seen. Okay, now usually general purpose strain gauges are made up of copper nickel alloy foil, but depending on the requirement and application, these alloys, they change. Now here is something which is called as gauge factor. Gauge factor is the most important property of strain gauge. Gauge factor is defined as a ratio of per unit change in resistance to per unit change in resistance. Gauge factor is given by delta R by R divided by delta L by L, whereas R is the original resistance of strain gauge when the length of strain gauge is capital L, that is before applying any external force. Now you apply external force, the resistance changes. This change in resistance is delta R, and delta L is the change in length. So here you will find that we can say that gauge factor for a certain strain gauge decides the sensitivity of strain gauge also. We know that sensitivity is equal to output divided by input. So here this is the rate of change in output, or this is the amount by which output of strain gauge is changing, whereas this is the amount of applied input. So gauge factor in turn gives the sensitivity of strain gauge, and therefore this factor has again a lot of importance. Now this strain gauge can also be expressed in this fashion. I mean, we have just changed the values. We have changed the values of this equation. This is delta R by R is equal to gauge factor multiplied by delta L by L. We all know that delta L by L is nothing but change in length divided by original length, which is nothing but the strain. So when you multiply applied strain with the gauge factor, it gives us change in resistance per original resistance of strain gauge. The gauge factor can also be written as gauge factor is equal to 1 plus 2 mu plus delta rho by rho divided by epsilon. So what is this? This one is contributed by resistance change due to change in length. This factor is resistance change due to change in area, as we know that not only length changes but the diameter also changes, and as diameter changes the area is also going to change. And this is resistance change due to change in piezoelectric effect. Okay, so gauge factor can be expressed as 1 plus 2 mu plus this. Now when the change in value of resistivity of a material is neglected, the gauge factor is 1 plus 2 mu. So this is all about gauge factor and stress and strain. All the best for your next session. Thank you.